So now we discuss some applications of double integrals. So una, recall, pag meron tayong function na non-negative and continuous over a region R on the xy plane, to get the volume of the solid between the region R and the surface z equals f of xy, then we just get the double integral of that function over R. So in other words, itong binibigay ng double integral ng f of xy over R is the volume between the surface f and the region R. So take note, to evaluate or to find such volumes using this method, kailangan alam natin yung surface na nasa taas, z equals f of xy, at saka yung region R na nasa xy plane. Okay, so as an example, let's find the volume of the solid enclosed by the paraboloids z equals x squared plus y squared and z equals 8 minus x squared minus y squared. Okay, so before we move to the actual solution, let's first illustrate kung ano yung nangyayari dito. So, first, a sketch of z equals x squared plus y squared. So, that's an elliptic paraboloid opening upward na yung vertex nasa origin. Tapos, yung other paraboloid is opening downward. Tapos, yung vertex niya nasa z equals 8. So, hindi masyadong important. Pero, again, opening downward to. Ayan. So, combining them into one Cartesian space, we get this illustration. Tapos, from this, try to imagine or try to find, can you find the solid na sinasabi dito sa example? Solid enclosed by the paraboloids. Okay, so makita nyo, etong part na to, diba? Ito yung solid na dinidescribe nung instruction natin. Ayan, so cleaning up itong illustration na to, we have this. Okay, so itong nasa taas is portion of the z equals 8 minus x squared minus y squared. Yung nasa baba ay portion ng z equals x squared plus y squared. So ito yung solid na gusto natin hanapan ng volume. Okay, so recall, do sa volume formula natin, meron tayong double integral ng isang function. Tapos, kailangan din natin ng region kung saan tayo mag-evaluate ang double integral. So, for this example, yung region na yon ay yung projection nitong solid na to, or pwede nyo isipin, yung shadow nitong solid na to sa xy plane. So, yun muna yung hanapin natin. Okay, so to start the solution, let's first find this region R on the xy plane. So, take note, itong region na to, from the illustration, mukha siyang circular region, pero let's actually verify that. Okay, pero take note, itong curve na to, mukhang circle, galing siya dito sa intersection ng dalawang paraboloids natin. So, dahil dyan, we compute yung intersection nila. So, we compute the intersection of these two surfaces by equating their z's. So, solving for this intersection, we just equate the z's, so we get this equation. And tapos rewriting that equation, transpose lang, and dividing, we get x squared plus y squared equals 4. So, napakita natin algebraically na indeed, yung intersection nila, and therefore yung region na to, ay isang circle. Moreover, nalaman din natin yung radius ng circle na yun. So, with this, napakita natin na yung projection ng solid ay isang circle centered at the origin of radius 2. Okay, so now we can find the volume of this solid, or at least set up yung isang expression for the volume of this solid. Okay, so again, ito yung hinahanapan natin ng volume. Yung approach na gagawin natin dito to find this volume ay, una, kunin natin yung volume between the upper paraboloid and the region R. Okay? Tapos, kung dito tayo magsa-start, take note, sobra to, di ba? Mas malaki to dun sa solid na hinahanap natin. So, gagawin natin is subtract natin yung sobra, which is yung volume under the surface ng z equals x squared plus y squared above the region R. So, bakit natin sinulat yung volume as a difference of these two? Kasi, turns out na yung volume ng dalawang to, sila yung binibigay ng double integral ng f of xy nila over the region R. So, for example, itong volume na to yung binibigay ng double integral ng 8 minus x squared minus y squared over R. And similarly, ang binibigay ng double integral ng x squared plus y squared over r is this volume. So, isusubtract natin yung dalawang to get the volume of the solid na gusto natin. Ayan, so this is an expression for the volume of the solid that we are finding. Tapos, some algebraic manipulation lang, using property ng double integral, since both over the region R to, we can combine them into one double integral. Ayan, so in the end, ito na lang yung gusto natin na evaluate. Yung volume daw ay yung double integral of this function here over this region R na na-describe na natin. So, yun na lang yung kailangan natin i-evaluate. Okay. So, at this point, meron na tayong 3 ways to evaluate double integrals using, so those are using vertical strips, dy dx, using horizontal strips, dx dy, and using polar coordinates, yung r dr d theta. So, in general, para malaman ko ano yung magandang gamitin, which of those three, nakadepende yun dun sa itsura ng region natin. So, for this example, tapos dahil yun din yung lesson today, dahil circular yung region R, gamit tayo ng polar coordinates. Ayan. Tapos dahil gamit tayo ng polar coordinates, sulat lang natin involved na curves in polar coordinates. So, simple lang to. Circle centered at the origin of radius 2. So, r equals 2 yun. Ayan. Okay, so setting up this double integral in polar coordinates, una, yung integral natin becomes 8 minus 2r squared. Tapos yung dA natin, again, ay r dr d theta. Tapos, to set up bounds for r, again, draw or imagine strips from the origin papunta dito sa region natin. Okay, so makikita natin, from the origin, natatamaan agad natin yung region. So, r will be from 0, from the origin. So, from the origin to the circle, r equals 2. Kaya, yung bounds for r ay from 0 to 2. So, tapos, yung bounds for theta, dahil isang buong revolution to, yung bounds natin for theta is from 0 to 2 pi. Ayan, so ito na yung setup ng hinahanap nating double integral using polar coordinates. Tapos to evaluate, same lang sa ginagawa natin before. Simplify the integrand, evaluate or integrate with respect to r, evaluate sa endpoints, simplify, tapos integrate with respect to theta, and evaluate sa endpoints. So, mechanical na lang yan. Okay, so in the end, we get that the volume of the solid we illustrated earlier is 16 pi. Okay, so that's one application of double integrals na I guess hindi masyadong bago sa atin. It's the volume under the surface. Pero pwede siyang gamitin, pwede siyang gamitin in other scenarios, katulad dito sa example na to. Okay, another use or another application ng double integrals can actually be used to find the area of a region. So if R is a closed and bounded region on the xy plane, turns out na yung area of R, yun yung lalabas kapag kinuha natin yung double integral ng 1 over that region. Okay? Okay, so to see why this is true, let's first illustrate kung ano yung nangyayari. So let's consider the solid that lies above the region R. So meron tayong region R sa xy plane. So let's consider the solid between the region R and this surface z equals 1, which is just a horizontal plane. Z equals 1. Okay, so yung solid daw, above this region R, tapos below the surface z equals 1. So yung solid na sinasabi dito is actually a cylinder. Well, hindi yung circular cylinder, pero yung mas general na cylinder. Ayan. So from this illustration, makikita natin, using just high school geometry, high school 3D geometry, the volume of such a solid is given by the area of the base times yung height, di ba? Kapag cylinder lang yung ating solid, yung volume niya, area of the base times height lang. Tapos, for this illustration, yung area ng base, yun yung area ng region R, di ba? Na hinahanap natin. Tapos, dahil z equals 1 to, yung height ay 1. So, simplifying, AR times 1 is just AR. So, yung volume nitong specific solid na to is equal to the area of this region, R. Now, okay, yung double integral ng 1, using yung volume interpretation natin before, this double integral gives the volume of the solid between z equals 1 at saka yung r. In other words, ito rin yung volume. Okay? Kasi z equals 1 yung integrand natin. Ito rin yung volume na kinompute natin earlier na napakita nga natin na equal sa area ng region R. So, this is the reason why itong equation na to ay totoo. So, again, pag gusto natin kunin yung area ng region R, we can use the double integral of 1 over that region R. So, gagawin lang 1 yung integrand pag gusto natin makuha yung area ng R. Okay, as an example, let's find the area of the region enclosed by this lemniscate r squared equals cosine 2 theta. So, ito siya. Ito yung graph ng r squared equals cosine 2 theta. It's one of the special curves in polar coordinates. Okay. Ang gagawin natin, yung approach na gagawin natin to answer this example ay we use symmetry. So, instead na kunin natin yung area ng buong thing, ang gagawin natin, focus tayo dun sa portion na nasa first quadrant lang. Okay? So, tawagin natin R, yung R natin, yung portion lang na nasa first quadrant. So, again, by symmetry, nakikita natin na yung area na hinahanap natin is just 4 times yung area nitong blue region na to. So, we just focus on finding the area of this blue region na tatawagin nga nating R. Okay. So, we have this. So, yung area is 4 times the double integral of 1 over this region, R. Okay, kasi nga, pag ginawa nating 1 yung integrand, we get the area of R. Ayan. So, now, let's evaluate this double integral. Okay, so dahil yung curves natin nakasulat na in polar coordinates, gamit tayo ng polar coordinates to set up this double integral. Okay. So, una, okay, yung 1 lang yan, walang magbabago dyan. Yung dA, again, ay r dr d theta. Okay. Tapos, yung curve pala natin na lemniscate, originally r squared equals cosine 2 theta. Syempre, dapat i-rewrite natin yan as r equals function of theta. So, we get r equals square root of cosine 2 theta. So, yun yung gagamitin nating form ng curve na to. Again, yung polar curves dapat kasi nakasulat as r equals function of theta. Okay, so anyway, so setting up the bounds for r, try to imagine or draw strips from the origin papunta sa region natin. From the origin, nasa loob na agad tayo ng surface, so yung lower bound for r ay 0. So, from r equals 0, yung huli nating matatamaan, yung outer curve natin ay from r to r equals square root of cosine 2 theta. Yung lemniscate, di ba? Yung outer curve natin. So, yun yung upper bound natin. Ayan. Tapos, yung bounds for theta, nakita natin, as we measure theta counterclockwise, magsa-start tayo sa theta equals 0, tapos hanggang pi over 4. Take note hanggang pi over 4 lang kasi yung pi over 4, diba, yun yung point or yung angle kung saan magzi-0 itong r equals square root of cosine 2 theta. So, indeed, hanggang pi over 4 lang yung ating theta. Ayan, so ito yung setup ng bounds for this double integral using polar coordinates. Tapos, the rest of the steps, mechanical na lang. Integrate with respect to r, evaluate sa endpoints, tapos integrate with respect to theta, and evaluate sa endpoints. So, we get this area. Turns out, yung area nitong pink region na to is just 1. And so with that, sana natutunan natin kung paano mag-evaluate ng double integrals using polar coordinates. So at this point, again, meron na tayong 3 methods to evaluate double integrals. May dalawa from rectangular, tapos may isa sa polar coordinates. Okay. Okay, so that ends our lecture. See you next time.